Howdy. Welcome back to the Bureau of Economic Geology's Austin Earth Science Zumarama. Today's speakers are Troy Kimmel and Bob Rose, both amazing meteorologists from the Austin area. We're pleased that Troy and Bob could join us today and talk about wild weather in Central Texas. Troy and Bob, the floor is yours.
Thank you very much, Linda. It's good to talk to you. Bob and I are very happy to be with you today. And as we always are, sometimes we're in person, sometimes we're available via recording, but nevertheless, it is what it is. And again, thank you for what you do with Earth Science Week every year and what the University of Texas has done. A lot of really neat stuff. Good morning, Bob Rose.
Good morning, Troy. Good morning, Linda. I'm really excited about talking about wild Texas, Central Texas weather today.
A little bit about ourselves. You can read about it on the bio, but my background primarily in broadcast meteorology, but I have been here at the University of Texas on the faculty, Department of Geography and the Environment for about the last 31, 32 years as a senior lecturer, and then before that as a lecturer, teaching. We don't have a major program in meteorology at the University of Texas, but we teach a weather and climate class and also an atmospheric hazards class as well. I do radio on Coke FM here in Austin as well. Bob Rose, tell us a little bit about what you do.
Well, similar to you, I also have a background in broadcast meteorology for about the past 25 years. Been working at the Lower Colorado River Authority, or LCRA. These are the folks that manage the Colorado River and the Highland Lakes through Central Texas. Of course, we live in flash flood alley, so weather is all a big factor as far as LCRA operations.
You know, Bob, so you're telling me weather is important for the Colorado River as it flows through Central Texas, right?
That's what I'm telling you, but it's important for everything across Central Texas, but especially the Colorado River.
Well, we talk about careers and things like that. That's important. One other thing I do at the University of Texas is involved in campus safety and security. I work as an incident meteorologist here at the university. So things like ball games, I work those. So I think that's important when we look at careers and different areas you can go into. And the wild Texas weather, let's put it this way, Linda, it keeps Bob Rose and myself occupied. And that's what we're going to talk about today. We're going to talk a little about wild Texas weather. I want to go over to the presentation now and let you look at the slides. Really some pretty cool pictures here of all the different types of weather across Central Texas. And that's where we really need to begin to talk, and where Bob and I, the foundation of what we do is so much, Bob, I guess the geography, especially of the state of Texas, right?
Absolutely. It plays such a big role as far as our weather goes, but it's also important to know where we are in relation to big weather features. Like, for example, to the east of us is the Gulf of Mexico. We're less than 200 miles from a generally warm body of water, the Gulf of Mexico, a huge influence on our weather. But out to the west, we see a natural desert. When you get out to far west Texas, around El Paso, and then going into northern Mexico, southern New Mexico, that's the Sonoran Desert. To the north of us is the Plain States, and then stretching all the way up into Canada. And so we're sort of in an intersection between all of these different features. And of course, where we live, we're also see a large geographic feature called the Balcones Escarpment. This is a rather abrupt uplift in the topography, or in the elevation of the land, going from the coastal plains into the hill country, and also has an influence on our weather. And we live in an area which is called the subtropics. We're not in the tropical region, but we're just outside of the tropics. So really, for many months out of the year, our weather is somewhat like the tropics. It's very warm, very humid, and we don't see a lot of rain sometimes.
It's the converging air masses, Bob, that essentially create let's put it this way, the challenges that we sometimes see in weather forecasting, as you point out, the maritime tropical air mass off the Gulf, the continental tropical air masses from the west, which are very dry and tend to be hot. And then we can get continental polar and also Arctic air masses in from the north. Guess what? They all sort of meet overhead. So what Bob says is extremely important for us to understand as we look at weather in Texas. And I guess in a way, we begin to look at these terms, Bob. And by the way, you can't get anywhere in weather forecasting without understanding these terms, like the word weather. Very simply, bumper sticker version is the current state of the Earth's atmosphere. In other words, you can say, hey, it's a rainy day. You're telling me something, Bob, what about the weather? The temperature outside is chilly. You're telling me something about the weather. And then, Bob, is that word climate. And I
Right.
guess the question that a lot of people ask, Bob, and are they sort of the same thing? And Bob?
No, they're not the same thing. The weather is sort of a snapshot of what's going on in the weather right now, but climate is more a collective state of the Earth's atmosphere or the weather, but over a much longer period of time. It might be a year, it might be several years. In weather forecasting, we tend to use 30 years as a good base for climate. So, in other words, we're taking a look at a long-term weather and also looking at the extremes. Sometimes the temperature gets really hot or sometimes it gets really cold. All of that put together is what we call the climate. So again, it's over a much longer period of time.
And that's important nowadays, Bob, when we talk about climate change and how potential climate change and what is happening in our environment results in these changes that over the longer term we've seen warming over the last, especially over the last 30 to 40 years, we've seen warming that we have to account for as part of this climate as well. It's really, in a way, you can look at today's weather, and I don't want you to necessarily hop from the fact that it may be 90 degrees today in Austin and say, well, that tells me something about the climate. But when you begin to put it all together, collective state, that's where we begin to talk about that word climate. So it is important. What about those people, Bob, that are in jobs like we're in? The word meteorologist, what does that term mean?
Well, that's really a term that describes a person who has gone to school. They have scientific training that studies the atmosphere and then will forecast how the atmosphere will change over time. That's what we call a meteorologist. We're a professional, a person who's actually gone to school to study how all these processes work. So that's the title given to someone who studies the atmosphere.
And Bob, we're always right. No, we're not always right. Indeed, weather forecasting is a non-perfect science. Yeah, we wish we were always right. But again, weather forecasting not being a perfect science. There really are no guarantees in weather forecasting. There are things in weather that we can tell certain days a little more, have a little more confidence. There are certain days when Bob and I have really tough days having to make decisions about the weather forecast. By the way, great pictures at the bottom. Bob and I've seen these pictures before, but pictures courtesy of the National Weather Service, the Weather Bureau, back in the days when everything was, pictures were black and white. Nowadays, what a Weather Service office looks like. National Weather Service office, where many forecasters are, like the office for Austin, San Antonio, which is down near New Braunfels. And another area that where meteorologists are involved as well is, of course, on the broadcast side. You see so many times in TV, if you know what TV is, times are changing. Not that many people watch TV maybe as they did 10 or 15 years ago, but we have a lot of people that are involved in forecasting weather for TV. But for private sector, there's a lot of different career fields in meteorology that involve private forecast companies. We have meteorologists that work for, professional football teams that help to forecast weather for games and stuff like that. So there's a lot of, it's really pretty interesting. If you think, I guess the bottom line, Bob, if you think that most people that are meteorologists that you see are on TV, they're not.
They're not.
It's pretty a small field when you consider broadcast meteorology.
That's true. Even things like utilities, local utilities throughout the country, many of them have meteorologists. So it's like you said, most of the meteorologists are not on TV. They're working behind the scenes.
So let's talk, Bob, for a second. And this is sort of a list. This is probably the most important list, Bob, that I put up for my classes at the University of Texas. You've got to understand what things, the elements, if you will, that are part of weather. I always tell people, jokingly to some degree, these are the things that we observe in weather. These are the things that we forecast in weather, and these are the things that we don't get right in the forecast in the weather occasionally. We hope to get them right all the time, but these are very important elements of weather. These are the fundamental things you need to understand when you look at weather and how we forecast the weather.
That's true. So let's get started. Let's talk about these. These are the ones that affect us, that all of us have some, the weather has some effect on for us. And the first one, the most noticeable, is probably the air temperature. How hot or how cold is it going to be when I walk outside? Do I need a jacket? Is it going to be something where I need short sleeves? So the air temperature, of course, changes not only throughout the day, but throughout the year, but a very important element and probably the most obvious part of what we call the weather.
And the humidity, Bob, number two point here. How much moisture is in the air? By the way, just because we have humidity in the air, do you see it? You don't in most cases. That a lot of water vapor in the air. Now, you may feel how muggy it is, sort of in response to how much humidity is in the air. But not only is humidity there and ultimately gets down to our points down below, clouds and precipitation, but another thing too is humidity. You'll learn more about this in science as you go along. Humidity actually is a source of energy for our atmosphere. It's a very important part of that. So, Bob, if you've got enough humidity, what might you have then? Point number three.
In certain cases, some of that humidity or water vapor may condense into what we call a cloud. Of course, all of us have seen clouds in the sky. That is that humidity where the temperatures have cooled enough that water has condensed out and we see them as clouds. And clouds take on all sorts of different shapes. And sometimes we can see them moving across the sky, and sometimes they just seem to hold in place. But that's always a sign of moisture or humidity being in the atmosphere.
I like to say sometimes that clouds are Mother Nature's way of really telling us what's going on in the atmosphere. When you get those clouds there, it's really Mother Nature's handwriting in a sense. And that's why it's important as science goes along and you learn more in your classes for folks out there that are watching, when you start to learn about some of these cloud names and things like that, that's important to understand that, because to understand the clouds is to sort of understand what's going on up in our atmosphere above. And so our next point, Bob, number four here is what? If you have enough moisture and you got to have clouds, you can have what?
You can have precipitation if the atmosphere is set up in a way to kind of squeeze some of that moisture out of those clouds. We call the fancy term precipitation. Now, most of y'all will probably know the term rain. That's what we see around here most of the time is a liquid coming down from the clouds and through the sky. But this precipitate or this vapor coming down from the clouds can also take on other forms. In the wintertime, we can see snow, we can see sleet, we can see even snow grains, things like that. All of that is called precipitation. They're the meteors coming down from the clouds.
Such as even like sleet and hail. Stuff
Right.
like that, hail and thunderstorms that we see.
Right.
That's a form of precipitation. One thing that we'll kind of stick with there for a second, Bob, is people ask about this. What about maybe like frost or dew in the morning that you see maybe outside, or maybe fog? Are they forms of precipitation?
No, they're not. That's not precipitation. That is condensation, really. This is where the air gets so full of water vapor or moisture, it just can't hold it anymore. It condenses out. But that happens down toward the ground. It's not happening in the sky or from the clouds.
One thing that's important, though, about that is even though it's not precipitation, as Bob points out, dew, frost, even fog are important sources of moisture in our environment, even though they're not forms of precipitation and not something, as Bob points out, that we measure in the rain gauge out here. So that's important. How about wind stuff? And the next couple of points I'll handle all at once here, but the wind direction. Folks, the one thing you always need to remember, you'll hear on TV or you'll see on the internet where people say the winds are south at 5. What does that mean as far as direction's concerned? Direction of wind is always the direction from which the wind blows. It's the direction from which the wind blows. No exceptions. If you hear wind direction, of course, the wind speed is just basically the air motion. The wind speed and wind moving in our atmosphere is really created by the unequal heating of the Earth's surface as a whole, and air moving from one place to another. In a lot of cases, wind speed, Bob, you're going to see it'll be stated in like miles an hour or things like that, just talking about how quickly the air is moving. What about this thing Bob called visibility?
Well, sometimes you can be looking outside and you can't really see much beyond, say, across the street. Something's kind of blocking my vision. A lot of times it has to do with the weather. It could be anything from fog to maybe blowing dust around, all of these things. This is what we call visibility. How far can you see? Something is obstructing that. And generally it has to do with either water vapor in the atmosphere or something that's gotten stirred up into the atmosphere.
We actually, Bob, here in Austin and around South Central Texas, remember this summer, we saw some African dust, if you remember that. And the last few weeks, we saw some more dust out of West Texas that came down to Austin one day, and visibility was down to about 3 or 4 miles for a while. In addition, a lot of you have seen some of the news reports from the big fires in California, in Wyoming, in Colorado, and how smoke can reduce visibility as well. By the way, visibility is a big thing at airports. That's very important for aviation safety. That's one thing that they look at. Hey, our last thing here, Bob, is something we call air pressure. And you know what? With air temperature, I feel chilly. Humidity, it feels muggy. Oh, I see a cloud. Oh, it's raining on top of me. The wind direction and speed, you can go out and look at the flagpole and see how the flag's oriented and see that. Of course, visibility is how far we can see. How's pressure treating you today, Bob?
Well, for most of us, we can't really feel the change of pressure, with air pressure. Air pressure is really nothing more than the weight of the atmosphere on top of us. And what we mean by that is, all the air molecules around us, they actually do have a little bit of weight. And then if you actually would put them on the scale and add up all those molecules that stretch from the surface all the way to the top of the atmosphere, there really is a weight to them. And then over the course of the day, that weight changes. Sometimes the air doesn't have as many molecules. We call that lower pressure. At other times, there are many more molecules than the previous day, and we call that higher pressure. And as storm systems move around, we will go from higher to lower pressure. And generally, higher pressure will bring us fair weather. Lower pressures tend to bring storms, low pressure systems, and that oftentimes causes precipitation.
Well, one thing too, Bob, to realize, and this is how important it is and how closely interrelated a lot of these weather elements can be. Does all low pressure produce clouds and rain?
No, it doesn't.
Does high pressure always produce sunshine?
No, it sure doesn't.
And with lower pressure, it depends on how much moisture is there. So we go back in the list and we have to tie these other things in there as well. Air pressure is one of the most interesting, and really from an educational standpoint, one of the hardest things to teach in a way, because it's everything else here is abstract. We understand it's very concrete, while air pressure is just something that is not something people can put their eyes on. And it makes it kind of difficult to teach somewhat.
That's true. Many of us may have experienced the change of air pressure, though. Just to say, if you've ever ridden an elevator in a tall building, and maybe you've gone up maybe about 20 floors, and by the time you get to the top, maybe your ears pop. What that is the air pressure is not as great when you're 20 stories up compared to the ground. You don't have as many molecules above you. So when you get up to that 20th floor, your ears have to adjust, and they'll sometimes pop. And that's one of the ways that we can understand the difference in air pressure around us.
I said this a second ago, most of these are abstract. Actually, what I meant was most of them are concrete. We can sense them, while air pressure is one of those things that's just harder because we can't see it. And about the only way you can do that is through the use of a barometer, and not everyone has a barometer at the house. So what are we here to kind of talk about today? How all this ties together with the dynamic weather of Texas. And we're going to go through and talk about each one of these, and then we're going to go through and take a look at a video just to show you some examples of each one. All of these are things that affect us in the state of Texas. Yes, there is winter weather somewhere, even though we don't see it that commonly here in Central Texas. And you have the more dynamic stuff, Bob, like tornadoes. And you have the stuff that's less dynamic than what? Like drought and heat. I mean, we know it's there, but it's not nearly as dynamic. What about that top one, though, Bob? That's the biggie. Everybody kind of wants to talk about tornadoes.
Oh yeah, there've been lots of movies about tornadoes, and of course, people have seen storm chasers, things like that. But tornadoes are very scary. I'll tell you that they can be big killers. A tornado is a rotating column of air that's in touch with the ground and it's attached to the cloud up above, and it moves. Sometimes it can have winds more than 200 miles per hour. It can be very destructive. You can see in the picture in the upper right corner, that's a representation, or that's not a representation, it's a picture of an actual tornado. Notice how it's in touch with the ground and it's attached to the cloud up above.
And that's actually a little history there, Bob. That's one of the most photographed tornadoes ever in history, and actually 1957 in Dallas.
Right.
That's the Dallas tornado back then. This is interesting down here, Bob, on the lower center. This is actually a Dallas tornado from last October. If you remember the tornado that went through at night, lightning is lighting it up here, but you see the tornado there. And again, remember, rotation on a vertical axis. So it's rotating this way and extending down toward the ground. Okay, Troy, we're sitting here. I put a big old technical term in here, Bob. What is a tropical cyclone?
Well, a cyclone really is just the definition of a low pressure system. That kind of, it's sort of a catch-all. You can see that all around the world, but a tropical cyclone is a special type of low pressure system, one that originates in the tropics. It's a warm core system, to be technical about it. But a tropical cyclone includes everything from a tropical depression, a tropical storm, and even hurricanes. So they're a special type of low pressure system. That's a tropical cyclone. We have a really good example here in the right-hand side. Troy will point to it. There's a hurricane right there. And in the middle of it, you see that feature we call the eye. That's the center. That's where the lowest pressure is actually located, where the air around it is rising very rapidly.
And another thing too, Bob, this is actually Hurricane Ike as it came up on the Texas coast a number of years ago. Folks, this is what Ike did. This is pictured on the lower left from Galveston, and that's I-45. That's the Gulf Freeway in Houston as you approach Galveston, and all the debris and all the high water that came up as a result of Hurricane Ike. Really a big force to be dealt with, and we've seen storms even this year. In the last few years, we saw Harvey. This is a big issue, especially in populated areas of the state of Texas. What about lightning, Bob? Everyone's had a chance to see lightning and hear the thunder that comes as a result of it. It's dangerous.
It's very dangerous. We live in an area that sees quite a bit of lightning per year. More than 40 days out of the year tend to have lightning. Very dangerous. Lightning is just a discharge of an electrical current between the cloud and the ground. And you don't want to be anywhere near that discharge or where that lightning is traveling. And of course, the temperature of lightning is more than the surface of the sun. It's extremely hot. It can kill people, and it can do a lot of damage as well. Whenever you hear thunder, which is a product of lightning, it's time to go indoors.
Bob, too, you look at this stroke that we have here. I'm not sure this is over Texas, but you see this stroke of lightning. You talk about how warm or how hot that current is. In most cases, that bolt is never much bigger around than the pin I'm showing you. I mean, it's only maybe a couple of inches. Yeah. So it's a very narrow bolt there. And believe me, even though lightning death tolls are down here in the United States, it's still a dangerous thing. And Bob, what you said is so important. If you hear thunder, be inside. Bottom line. By the way, Bob, can you go to a car?
A car is actually one of the safer places to be. If you can't get inside a house, probably your next best bet is to get inside a car.
But Bob and I are going to share a secret with you, though. Most people will tell us that it's because of the rubber tires, and it's really not. It's not because of the rubber tires on the car. It's because of the chassis effect of the vehicle, the cage that the car is. If lightning hits it, it'll divert it around you if you're inside the car. So it's not really the tires that offer the safety, but a lot of people think it is. How about this hail thing, Bob? And you see lower center, two large hailstones that look like to me to be about baseball size. This is a big factor in Texas.
Absolutely. We see hail around central Texas quite a bit throughout, especially in the springtime, sometime in the fall as well. And what you're showing there is a pretty good example of what we'll see in almost any given year. We'll see some really big hail around our region. And of course, we go back to precipitation. This is a form of frozen precipitation that's part of a thunderstorm. You have to have a thunderstorm to produce hail. But remember that these are going to be falling from a cloud way up in the atmosphere. And sometimes they can have a velocity of about 80, 90 miles per hour when they hit the ground. So they can not only do a lot of damage, but they can hurt people as well. So this is a really big factor, not only for our cars and our homes, but also for farmers and ranchers. They can do a lot of damage to crops that are out in the field.
Absolutely. And Bob, we know cases even in Texas where we've had deaths as a result of hailstones hitting people. 80, 90 miles an hour coming at you from the skies, like throwing a baseball at you in a way. And we know in other parts of the world, in Eastern Asia, where population densities are greater, we've actually had hundreds of people killed or injured in hailstorms. So please keep that in mind. The larger it gets, the more severe the storm is. Let's talk about floods and flash floods. Boy, this is a big one around Austin and South Central Texas. It's something, Bob, having been closely associated with the job position you're in the past myself, this is a big, big issue in the state of Texas, both from river floods as well as flash floods.
That's true. You know, it is said that we live in Flash Flood Alley here in Central Texas. There's a lot of factors similar to what I talked about earlier with the geography, but we have the Gulf of Mexico, we have the Balcones Escarpment, we have active thunderstorms that come at us from West Texas. All these factors put together, we tend to see not only a lot of rain, but a lot of heavy rain at times. Then when you put also into account the geography, we have a lot of hills where water, of course, will run downhill and it starts to gain momentum. And that's what causes our flash floods. A lot of times storms will develop. They won't move really fast, but they can put out a lot of rain in a short period of time so that we get flooding and we get flash flooding. It can happen in a matter of minutes at times. So something very serious. It's a big killer here in Central Texas.
And one thing, too, we know is people do not appreciate the power of moving water. Folks, if water's moving along at 10 or 15 miles an hour, even an adult can be swept away. So again, remember what the National Weather Service says. Turn around, don't drown, don't try to get into moving water because you're going to lose that battle. And we have every year in this part of the state of Texas where people die is because of flash flooding. Hey, let's talk about the drought and heat for a second. And you see the flood picture down the lower right down here, but I also have a great picture that Bob gave me. This picture of Lake Travis. Bob, tell us, obviously, it's a little drier than normal. If you look at this picture of Lake Travis, and this picture is taken up around Mansfield Dam, right?
That's not too far from Mansfield Dam. It's actually a lot drier than normal. This was taken back in the drought period of about 2011, 2012, where it didn't hardly rain through 2011. And, you know, we go through these periods here of drought where the rain just doesn't want to fall for a long period of time. And in this picture here, Lake Travis is only about 1/3 full. Hard to believe. But you know, we do see this from time to time. But then, of course, we go back into our wet periods as well.
You know, Bob, the thing you pointed out earlier is because we sit in this adjacent area between semi-arid and arid areas out to the west and moist areas out to the east, with any type of changing climate patterns, it's very easy for that drought to spread back into Central Texas, and something we see, and probably something that we need to recognize a little more in a changing climate, especially over our area of the state. So, and by the way, it affects us all. It's not anything that's real dynamic, but Bob can tell you, folks, when we start getting very low water levels, it begins to affect prices of water and the availability of water. And especially in a growing population, that's really, really important. Hey, the last one, we'd like to talk about winter weather and chill and the snow picture here. Folks, this can be a big issue in Texas. West Texas, North Texas, Bob, they can see blizzards. We don't see blizzards here. We don't see snow all that often, but at the same time, we see ice, and we've seen snow even down in the last couple of years all the way to Brownsville.
That is so true. You know, a lot of people just think, oh, it's always hot here in Texas. But, you know, we do get every now and then we get some pretty chilly weather that can come through. And if we have that moisture in place at the same time, yes, we can get snow like Troy mentioned, but probably one of our biggest safety or from a safety perspective, one of the biggest things that we have is ice, where sometimes we can get just a narrow or very thin layer of ice on top of all of our roadways and on top of our homes and things like that. People can slip on sidewalks when you get that ice. And of course, it makes it very hard to drive. We're gonna have lots of accidents when that happens as well. But we do see winter weather here from time to time. You're right.
Well, I'll tell you what we're gonna do now. This is what I call our Zumarama Dynamic weather. This is where we show you some video. Bob and I've gathered up some of the best of the videos, and I'm going to share another screen with you. As I do that, I want to tell you about a picture, just show you a picture. It's one of my screensavers that I've got on the computer here. I love this picture. You're talking about weather. This is off the west coast of Washington State. Out near Forks, Washington. Took this picture a number of years ago. The sun is setting with high level clouds looking out to the west. I just love this picture. So it's a good, again, this is weather. This is looking at weather, and it's just really, really a nice view. But I told you this is a Zumarama dynamic weather. So the first thing we're going to look at here is a picture not that far in the past here. This is from a hotel room, Bob. It's actually looking at a tornado, a water spout, essentially, Bob, that forms over the ocean, then moves over the land. I want you to watch the bottom part where it crosses the beach here. Look at the debris as well. It's flying in the air. And then look at the debris flying on the ground in just a second.
Keep in mind, this tornado originated over the water, so it's likely not only sucking up water, but it was probably sucking up fish as well, things that are in the water.
Yeah, I think I'd like to not have the umbrella sails there. All those things were kind of flowing in. Remember, look in the tornado here. Now it's a tornado, it's over land. Everything is converging. Air converges in a tornado. It comes up and then rises from there.
It literally formed right in front of me.
Really kind of cool video there. There's another picture. This one's closer to home. This is over North Texas from a tornado about a year or so ago up near Canton, Texas. Our next piece of video that we're going to look at here is actually in Texas. This is in North Texas not too long ago up around Canton, Texas. And this is a tornado. This is video of the tornado on the ground, folks. And again, remember, everything's converging.
We're good.
Bob.
Freaking gosh. Oh! Power flashes on the road right in front of us.
Oh.
Big time debris. Oh God.
One thing we probably should point out here, Bob and I'd point out, is these people are actually chasers where they've studied the science a little bit. They're in a pretty safe position. That's one thing we
Just
really like to see. But this is on the ground. What is really kind of cool about this is at the same time, Bob, that those pictures were being taken, there was also a scientist, drone operator up around Canton at the same time and taking some really amazing pictures from a drone. This is courtesy of our friends over at the Weather Channel. No audio with this, but it's amazing.
This is a view up at about 150 feet or so. We're looking at the tornado itself. So we're a little bit different view from being down on the ground, but notice that large funnel, and you can see that the condensation funnel, you can see something swirling around. The air is actually spiraling into that funnel and then going up into the cloud.
Really beautiful view for something as dangerous as it is. These drones and people learning the science a little bit, being safe, we're really getting a lot of good information because, Bob, this is important. This video is important to scientists.
Absolutely. Data from this actually helps us understand a little bit better about how tornadoes operate, what causes them to form and persist. So this is not only really cool video, but actually is a big help as far as advancing us to understand a little more about them.
So that's our tornado part of Zumarama here for just a second. I want to talk about lightning for a second. I like this next video that Bob and I have chosen to use. It actually is video from here in Austin. I'm going to let it run and we're going to increase the size so you can see it. But this is actually time lapse from back in 2017. One of the strokes hits the UT Tower. Wow. We actually have that video. And again, through this time lapse, just keep in mind what Bob mentioned about that stroke that we see that occurs there and how dangerous it is and the heat involved with that. You see the strike also in downtown Austin.
And of course, the UT Tower, like most of the buildings, they have lightning arresters at the top of the building that take those charges and direct them down to the ground. So the people inside the building should be safe. But in most cases, lightning will strike the tallest object around. So if you look at that picture, you can see in that vicinity, that's about the tallest object around.
Absolutely. Absolutely. How about a little bit of hail just to throw in for good measure? Today, this is some video that Bob and I use a lot. It's actually from Phoenix. I want to kind of walk you through this. This hailstones are, in some cases, as big as baseballs, Bob.
Amazing. And we're talking, about 4 inches in diameter. But again, we're falling to the side very fast. And most dramatic are getting cool. But it's also doing a lot of damage. The roof around you just hear all the noise from all of that. Oh my God. But yeah, you don't want to be caught outside in a storm like that at all.
And you can see something Bob referred to a few minutes ago, and that's the damage to vegetation. It's not agriculture in this case. You see the damage to vegetation as well. A little bit of flood video today in our Zumarama dynamic weather experience. This actually comes from the city of Austin, this video. This is a couple of years ago. This is down near Barton Springs. And again, does everyone understand what Bob and I talked about? We talked about the power of moving water, how dangerous it is. If you're out in that, you're downstream. If you're in a vehicle and you try to drive through that, Bob, you're downstream.
And you notice that's Barton Springs pool there. This is where people normally swim, and it's a more or less a gentle pool. But in this case, all the water rushing down Barton Creek is coming right through that pool area. You don't want to be anywhere near that water. It can definitely sweep you away very quickly and likely drown. No one's going to be able to get out there and rescue you with water that's moving that quickly.
Good point, Bob. Last bit of video that we have today is really something pretty interesting that is courtesy of our friends at NASA. We wanted to show you this. This is actually Tropical Cyclone, a Hurricane Sandy, back a few years back. But this is a nice representation of winds in our atmosphere. And you have another area of low pressure over here. You can tell because it's turning counterclockwise. And these are all where the colors are actually stronger winds. 4,000 or 5,000 feet above the ground generally. So it shows us what? That there's not one storm that operates by itself. It's operating in tandem with what? The other circulations that surround the Earth itself. So it's really kind of a nice view here, Bob, as you saw the landfall, if you will, of Sandy. So really kind of cool pictures there. And with that, Linda, that is our presentation on Texas weather. Wild Texas weather, in fact. And we want to talk for just a second, if you can let us see maybe our Zumarama page, talk a little about some of the things that are there for our classrooms that may be watching today. There's some resources that I added and Bob added toward the end of the page. And one thing, Linda, that we really strongly recommend is something called the National Weather Service jet stream. It's if you do a Google search or you go to our page on our Zumarama page at the bottom, you'll see it. It's an online school for weather. And when we click our way in, not only there more information than most people will ever care to know about the weather, there's actually the opportunity, Linda, you've pointed out to us, to actually do some, I would call them sort of lab exercises with certain things in weather. We look at ingredients for a thunderstorm. Bob and I both know you need moisture, instability, and lift, and you see the life cycle of the thunderstorm. But the question becomes, they have quite a few learning lessons in here from the National Weather Service as well. And guess what? You can do some of this stuff. We can do them in the classroom, or you can even do some things like this at home. And some pretty good learning lessons with this. And I strongly recommend, again, the National Weather Service jet stream. Just do a web search for that or go to our Zumarama site and you will find that link where you can go in there, and a lot of learning lessons and a lot of cool weather stuff, Linda.
Yes, thank you so much, Bob and Troy. I really appreciate this. Earth science literacy is so important. And one of the things I like to say is there's relevance to our daily lives. And your talk today really highlights how important it is to learn about weather and climate and how meteorology is a career path for people. So thank you so much for sharing all this with our students.
Linda, it's always a pleasure. Bob, I know you think the same as well. We appreciate what you do. Yes. Especially this year with the outreach and what we have to sort of this year make lemonade out of lemons in a way. And I will tell you that Linda and Aaron and all the people that have been involved in this have done an amazing job of getting this all done so that we have the opportunity to enjoy this even with our 2020.
It's a pleasure, and it's just wonderful that you guys took the time to join us. And I know it's been years that you have shared this information, and I really appreciate it. Today we'll close, and I thank you very much. For those of you watching on YouTube, if you have a question you didn't have answered, leave a comment below, and we'll do our best to get an answer to you. And also check the description on the video links for more information on our website. And don't miss our next talk with the Bureau's own Gulf Coast Carbon Capture Group on CO2, too much of a good thing. That's next Tuesday at 10 o'clock Central Standard Time, and soon thereafter on YouTube. Thanks for watching, everyone. See you next time. Goodbye.
Right.